for you. It's different in the sense that it doesn't require a microcontroller, there's no programming or anything. It's actually a very simple passive electronic device that I needed to build in order to solve a problem that I had creating videos here in the workshop. Now, the problem I had started off when I bought this little HDMI capture device. This device lets me take the HDMI output for, let's say, a Raspberry Pi or a workshop computer and record it onto an MP4 file so I can use it as part of my videos. And the thing I liked about this particular one is that it has a microphone input that you can use that has a soundtrack to that capture. Now, I wanted to use that with the existing sound system that I have here in the workshop. I have a mixing console that I feed my microphone into. I just wanted to take the output of the mixing console and feed it into the microphone input, and that's where I ran into a problem. Now, I started doing this first with this cable. It's a very nice cable that has two RCA connections on one end, and it has a 3.5 millimeter plug on the other end. I took the two RCAs and plugged it into the output of my microphone mixer, and the 3.5 millimeter plug I fed into the microphone input of the HDMI capture device. And then I made a test recording, and the sound was absolutely horrible. It was distorted, it had all kinds of noise and popping sounds and things in it, and thinking about it, it's pretty obvious why that would happen. There's actually two reasons. The first reason is that the output from my microphone mixer is far too high for the input that the microphone input needs on the HDMI capture device. And even when I turned the output level down, it was still distorted and noisy. The second reason is that microphone inputs have a DC signal that they use to power the microphones that are normally connected to them. But of course, I don't need that DC signal because I'm feeding the sound from the output of my mic mixer. So what I needed was a device that could both reduce the level and remove that DC signal. And I built one. It's this little box over here, and it simply has connections on each side. I use RCA connections because that's what works in my application. I have an input that I feed from the mic mixer and an output that I use with that same cable that I showed you that gets fed into the HDMI capture device. Now, you can use this for other applications as well. Let's say you had your iPhone or your Android phone, and you wanted to use it to feed into the microphone input of a computer or another recording device. My digital camera also uses stereo microphone inputs, for example. You could use this box to do that. And you can also build this any way you want. You don't need to put RCA connectors on the way I did. You might prefer to have 3.5 millimeter connections, or maybe even build the whole thing into a cable without any connectors at all. But at any rate, since I couldn't find a commercially available device that did this, I thought I'd show you how I built this. What I'm going to do is show you the schematic that I came up with and how I actually assembled this little box. So if this interests you, then stay tuned and I'll show you how to build one of these. Now, when I was developing my lines and microphone adapter, I needed a way of prototyping it, and I found the Sonos breadboard wasn't a very good solution, because the Sonos breadboard just picks up too much electrical noise to make it practical for prototyping an audio circuit. So I just flexed an RCA cable and sort of hung my components free form on the cable, which is pretty crude, but it actually did work, and I certainly wouldn't recommend this as a permanent installation. But for developing the circuit and getting the component values fine-tuned, it worked very well. So having said that, let's take a look at the schematic. Now, here you see I've got an input drawn as an RCA jack. Now, of course, you can use a different input, like a 3.5 millimeter jack, or just wire directly off the cable. Now, across the input, I've tied a 15K resistor to ground. This should provide a constant load for the line out on the device that I'm using. Now, you could use any value from about 10K to 22K, and it would work just fine. After that, I've got a 330 ohm resistor. And what this resistor does is it drops the level a little bit, because microphones don't use as high a level as line level, so I want to drop the level a little bit. Again, this isn't a critical value, anything from 220 to 470 ohms would work fine. Now, after that, I've got a capacitor. I use a 1 microfarad electrolytic capacitor, but you could use a tantalum capacitor, and any value from about 0.47 to 2.2 microfarads would work just fine. The purpose of the capacitor is to block the DC voltage that's applied to the microphone input. On most devices, we apply that to power the microphone, but we want to prevent that voltage from going back to our line device, so that's why I have a capacitor there. And finally, I've got a 1.5K resistor from the output of the capacitor down to ground. Now, this was very important, and it was sort of a missing component. I found without this, I would get popping noise in my circuit. And what this does is it provides a constant impedance for the microphone input. And then that just goes to my output, which is the input to my microphone. I began construction of the project by putting the components onto the small piece of perf board that I'm using as a circuit board. I constructed mine starting from the input, working my way up to the output. I used the 4-pin male header with the outer 2 pins as the left and right hot lead, and the center 2 pins as the ground. I then connected the 15K and 330 ohm resistors to these, followed by the 1 microfarad capacitor. Afterwards, I connected the 1.5K resistor and the other 4-pin header that I'm using in an output connector. After wiring up the circuit board, I applied some dry transfer lettering to the cabinet that I'm using to label the input and output, and then installed the RCA jacks. Next, I connected the wires that I'd already installed the 2-point headers on to the RCA jacks. After that, I installed the circuit board onto the spacer that I'd mounted in the center of the cabinet. I connected up the wires, and then installed the cover. Finally, I added the rubber feet, and I was done. So I tested the box after I built it. I fed the output of my microphone microphone mixer into the line-in on the box, and I fed the microphone out connector on the box into the microphone input on my HDMI capture device, and the result was very clean audio that I can now use to make more videos for everybody. So the box was a success. Now, if you need more instructions for building this, I've got an accompanying article on the DroneBotWorkshop.com website. You'll find a link to that article in the description below the video. So if you need the schematics and a little bit more help in building a box like this, just check out the article. Now, if you want to find out more about the videos that I make here on the DroneBot Workshop channel, please subscribe to the channel. That way you'll get informed every time I release a new video, whether I make it with the box or without the box. So until next time, take care of yourself. Hope to see you soon here in the workshop. Goodbye for now. The Arduino Uno is a very versatile little microcontroller that you can make use of for all sorts of different projects, but it isn't the only member of the Arduino family. The Arduino family actually consists of a number of different boards and chips, each with their own specific advantages and disadvantages. Today in the workshop, I'm going to show you some of these different boards and chips and how you can use them in your own projects. So stay tuned and welcome to the workshop. Hey, welcome to the workshop. Today what I'm going to be doing is taking a look at some of the different Arduinos that you can use in your projects. I like to call these members of the Arduino family. Now, the Arduino, of course, is a very common microcontroller device. It's inexpensive and can be used for all sorts of projects, robotics, IoT projects, virtually anything that you can think of, you can build with an Arduino. Now, the most common Arduino is this one over here, the Arduino Uno. The Uno is a very common microcontroller board, very versatile. It's got 14 digital I/O ports plus 6 analog input ports. It has a USB connector on it that you can use both to power the device and to program the device, as well as a power connector that you can connect to a 12-volt supply or to a 9-volt battery. So it makes it very easy to take Uno projects and put them into a permanent enclosure after you're done with them. But there may be reasons that you don't want to use an Uno for your project. You might find that it's too big, or you might even find that it's too small. So there are a number of other Arduinos you can use, and I've got a few of them over here on the workbench with me. Now, on the large end of the scale is the Arduino Mega. The Mega, as you can see, compared to the Uno, is much, much bigger. It's got a lot more digital I/O ports, more analog input ports. It's also got more memory, so it can handle larger programs. So if you find that you're running out of space with an Arduino Uno, you might want to consider using a Mega. Megas are used in large projects. A very common use for the Mega is that's the controller board in 3D printers. You'll see a lot of designs that make use of the Mega for that. On the other end of the scale, though, you might want to get a little bit smaller. And this is the Arduino Nano. Now, the Nano is a very versatile device. It's as powerful as the Uno. In fact, in many ways, it's even got a bit more power because it's got 2 extra analog input ports. And as you can see, it's quite a bit smaller than an Arduino Uno. It also has its own USB ports, and you can program and develop things on the Uno and then translate your design onto a Nano to get a much smaller part that you can build a smaller device with. If you want to go even a little bit smaller and you don't need the USB ports, you can try the Arduino Pro Mini. I've got a Pro Mini here just beside a Nano just so you can compare the size. It's a little bit smaller, and the most notable difference between the two is that the Pro Mini does not have a USB port on it. You use an external device to program this. There's a lot of times where after you build the project, you'll never need to program it again, and for that, the Pro Mini is a good choice. Another thing about the Pro Mini is in addition to the normal 5-volt version, which is the one I have over here, you'll also be able to get 3.3.